Alright, so this is going to be part 2 of learning how to program in C++. And part 2 is going to be your first C++ program. We're actually going to use Visual Studio. We're actually going to write a real program that actually does something. So unfortunately, one of the downsides of C++ is that it takes a bunch of lines of code to just even get started. But once you get used to it, you'll see it's actually not that bad. It's a little bit of a tradition when you're learning how to program that your first program says hello world, and so that's what we're going to do. I'm going to start out just with the program being written in Windows Journal here, and then I'll move over and use Visual Studio and show you what that looks like. But I'm going to use Journal first because I want to be able to highlight different parts of the program and show you the different pieces here. Okay, so I already have it written out here. So this is just about the smallest program you can make in C++ that prints something out to the console. The console, if you're not familiar with that term, is that black window that you will always see. Hollywood loves to show hackers in front of a console, that black window with either white or green text. That's the console. And all of our programs are going to run on the console. Alright, and so this is the first program. It looks like there's a lot here, but if you break it down, you'll see there's actually not too much. Alright, so let's start off at the top here. The first thing that you have are these two lines. It says red, pound include. This is a little left bracket, this is a less than sign, IOStream, and then a right bracket. What this statement is doing is this is basically saying that we need to bring in someone else's code to help us. If you recall from the last video, I said almost nobody writes 100% of the code that they use, and here we are already in our first program, we're using someone else's code. All right, and IOStream is a library that exists. It is standard in C++, it is always included, and this library helps us with doing both input and output. Alright, that's what the I/O stands for, input output stream. And we need this one because we are going to output to the console. And so in order to make our program work to begin with, we need to include it. We need to bring this into our program so our program can do what we need it to do. This next line, unfortunately there's not a lot I can say right now to explain why this line is needed. In a later video, I will go into depth of exactly what this line is doing and why we need it, but suffice it to say this using namespace std, std stands for standard, and then a semicolon. This line right here allows us to use the commands in IOStream the way that I'm going to show you how to use them. Alright, so in order to begin, we need these two lines in our program. We're just going to type them anytime you're going to do any kind of printing to the console, which is pretty much going to be always. You're always going to have these two lines at the top of your code. Alright, once you have those, we come down to a very important part, and that is the definition of main. And I'm going to include these two curly braces too. Alright, every program needs a place that it's going to start. The compiler cannot guess where it needs to begin your code. Once it starts your code, it's just going to go top to bottom and run all the commands you write, but it needs to know where to start. And the place that it starts in C++ is in this function called main. Alright, you can define it a bunch of different ways, but this is the way I'm going to define it in these series of videos. And it's going to read void. That's return type. You're going to learn more about that later, but for now, just know that you need it. Void space main, all lowercase, has to be spelled that way. A left parenthesis, and then a right parenthesis. Then on a new line, you're going to have a left curly brace, and then at the end, you're going to have a right curly brace. And the key is that any code you put in between these two curly braces is going to be the code that gets run in your program. So what we're going to do, we are going to define this main function with these curly braces, and then we're going to put the code we want to run in between those two curly braces. And once we do, it's going to run from top to bottom, one command at a time. So if you've defined main and you have a place that you can actually run some code, now we actually get to the part that actually prints out to the console hello world. And we'll use a different color for this. Alright, so to start off with, we have the cout command. Alright, and what cout stands for is it stands for console output. This is what we're going to use anytime we want to print to the consoles. We're going to use cout. And the syntax for cout looks very strange. And what's even more strange is that it's pretty much the only thing that you're going to use in C++ that uses this kind of syntax. There are a couple of other things, but not very many. So cout is going to be a strange one that you're just going to have to get used to. But we started with this cout command. And then we're going to tell it what we want to print. And in between all the things we want to print, we're going to have this strange little thing here. We're going to have these two less than signs. Alright? And what this basically means, cout is a command that we can chain together where we just keep on telling it to print things out. And we're going to separate the things that we want to print out with this little double less than right here. And so what this is saying is print out, use our little less thans, this thing, use our less thans again, and then print out something else. Alright, so let's look at what we're actually printing out here. I'm running out of colors. We'll just reuse yellow. Alright, so the thing that we're going to print out first is this hello world. Alright, the thing to notice here is that we have these little double quotes. We have a double quote, hello world, and then another double quote. This defines what's called a string. Anytime you want to print out a bunch of characters in C++, you need to define them inside a string. And a string is defined as any amount of characters in between double quotes. Alright, so the fact that we're going to print out hello world means that we need to define a string that says hello world, and that's all we do to do it. We just do double quote, hello world, double quote to close it. So cout, sprint to the console, our little separator, less than, the string hello world, less than. Alright, and then over here we have this strange little thing. Let's pick a different color, even though I've used them all. Oh wait, I didn't use cyan. And L. Alright, so I told you already that we use this little double less than to separate things we want to print out. I said cout, double less than, hello world. So I've already printed hello world. So what's this end L? And what this stands for is end line. And what that means is after I'm done printing hello world, I want to go to a new line. Alright? If I didn't do this, whenever I run my program, anything else that gets printed out is just going to be tacked right onto the end of hello world because I didn't tell it to go to a new line. It's like a carriage return in the typewriting world. Okay? So that's almost all of this line. Cout, less than, our string hello world, less than, end L, go to a new line. Alright, but then on the end, there's this super important semicolon. Every statement in C++ needs to end with a semicolon. We already saw it up here in this using namespace standard, but we see it again down here at the end of our print statement, at the end of our cout statement. You have to have it. If you don't have it, the compiler will complain. This goes back to the whole compilers are strict thing. Alright, so if there's anything there that didn't quite sink in, maybe go back, watch it again, understand what you don't need to understand exactly how each line is doing it, but it is important to understand what the purpose of each part of these lines is. Alright, so with that, we're going to take this program and we're actually going to go into Visual Studio. and we're going to make this run. Okay. So I'm going to be using Visual Studio C++ 2010 Express. It is quite old, but it is actually the newest version that will run on this old Vista laptop, so that's what we're going to use. Fortunately, it doesn't really matter. Visual Studio has not changed that much since 2010, especially for doing the simple programs we're going to do. There's no difference. Alrighty, so we're going to start off here. When I open it up, I have just this, nothing's actually open yet, but this is what Visual Studio looks like. I'm going to start by going File. I'm going to say New Project. All the code that I ever do is going to be run inside a project. It also is called a solution. That's what Visual Studio likes to call it. Mostly sounds like a crappy buzzword, but that's what they call it. Okay. All right, New Project. Under this, there are a bunch of installed templates. So Visual Studio can make a lot of different types of projects. What we're going to do is we're just going to say under Visual C++, empty project. And now down here, there are 3 parts that need to be filled in. There's this name. I'm going to call my project Hello World. This cannot have spaces in it. So whatever you call it, do not put spaces or special characters. Just use straight up text. So you can see that I just call it Hello World, no space. You also notice that it changed the solution name at the same time to Hello World. You almost never have to change that, so just let it do its thing. And then the location where you actually want your code to go. These solutions need to be in their own folders. I have already picked a nice folder for this to go in. Underneath this folder, it's going to create a new folder called Hello World, and that's going to have my program in it. Okay, and it's this little checkbox, Create Directory for Solution. That is what actually creates that folder. I want to leave that checked because I want this project to be on its own. I want everything to be contained in one nice folder so that things don't get messy and break. Alright, so empty project, Hello World, Create Directories for Solution, we're good to go. Click OK. Wait for the little spinny thing to finish. Alright, and here we go. Now I have an empty project. And as the name would imply, there is nothing in it. It is an empty project. So to actually get some code, what I'm going to do, under this little solution, this basically right here is going to look exactly like just a folder directory. It's going to show you what's actually in your project. Okay, at the top is the solution Hello World. In the solution there's a project called Hello World, and then there are these 4 folders: external dependencies, header files, resource files, and source files. Source files is where I'm going to put my code. So I'm going to right click on source files, say add new item. And when I add a new item under source files, I get this new little pop-up. Again, there are a bunch of templates. Visual C++ is what I want. Down here, I want C++ file, .cpp. And then it's going to make me enter a name. I'm just going to call it Hello World. Don't touch the location where it goes. Let it pick where it's going to be. And click Add. Alright, and now we can see that under source files, now I have a file here, helloworld.cpp. Alright, I have an empty file. This is just a text file. I can type whatever I want, but I'm going to type the exact program that I had before. You will notice one thing to keep in mind as you're doing your code is to keep it clean, okay? When you see this main, you'll see these 2 curly brackets. Anytime you have curly brackets, you should always indent your code. You can see if I kind of jump back over here into the journal, you can see that right here I had this indent, all right? And it can either be a tab or it can be 4 spaces, but whatever it is, anytime I have these two curly braces, I always need to indent the code over. And all of the code that I'm going to do is now going to follow this new indentation. Alright, and you do this to keep your code nice and clean. The key is that code is read a lot more than it is written. And so if you need to keep your code nice and clean so that you can read it, and others can read it. And not only that, but this is also, by keeping your code clean like this, you are also going to have an easier time catching mistakes that you might have. I was actually in it was actually kind of sad. I was interviewing someone. She was interviewing for an entry-level programming position, and we gave her a problem to do. It was actually quite an easy problem, but she did not keep her code clean. She did not maintain this indentation structure. And as a result of her doing that, she had a bug in her program. She had the wrong number of these, and she spent about 15 minutes trying to fix it during an interview with everyone watching. It was very embarrassing. Don't be like her. Keep your code clean, and don't make mistakes because you don't keep your code clean. Alright, so in line with keeping my code clean, you'll see that Visual Studio actually helps you do this. Alright, I'm not just making this up. Visual Studio, you can see as soon as I hit enter, it put my line already on a tab over. Alright, and so now I'm going to type my cout statement. I have my double quotes. You can see that when I make things in double quotes, it turns it red. That's just it doing its best to make this easier to read by showing me that this is a string. Okay? And L to get a new line, and then a semicolon on the end. Alright, so there we go. I have my program. I don't even bother. Running code is so common in Visual Studio that I don't even bother finding the run command up in the toolbar anymore. All I ever do is Control F5. Control F5 runs your code. When I hit Control F5, it says this project is out of date. Hello World Debug 132. Would you like to build it? Build in Visual Studio means compile. The answer is yes, of course I want to compile it. Alright, and so we can see the IDE down here. It says build started. Right now it just showed me the output of the compiler. It started the compiler for me with this code, ran it through, and you can see at the end it said build 1 succeeded, 0 failed, 0 up to date, 0 skipped. This 1 succeeded, that's a good thing. That means that we didn't make any mistakes. Unfortunately, you'll notice if you were paying attention and if the screen capture got it, there was a console window that flashed up and then disappeared right away. This one actually, I believe it is a bug in Visual Studio 2010 that it doesn't do this already. I don't think the new ones do this, but if you ever have this problem where it doesn't show you your program, you can just go up to Project, Hello World Properties. Under Configuration Properties, Linker, System, there's this one called Subsystem. And this should have been set to console. So once I set that to console and click OK, I can rebuild it again, Control F5. It says this project is out of date. I changed the properties on the project so it has to rebuild it. Would you like to build it? Yes. So it builds it again, and aha! I have a console window, just like they show in the movies, and up here at the top, Hello World. Press any key to continue. So this code right here was able to print Hello World to the screen, and this print any key to continue is what lets me actually see what the output of my program was. Okay? And that right there is your first C++ program. Alright, so if everything went perfectly in yours as you follow along, you should have seen the same output. Unfortunately, we are human and we make mistakes, and so you might not have seen that. So I'm going to go over what it looks like when you make a mistake, and I'm going to cover a bunch of common mistakes that people will make on a simple program like this. It seems like it'd be too small to make mistakes, but I promise you people do it all the time. Alright, so the first and most common mistake. Let's say that I remove that semicolon. I said that every statement in C++ needs a semicolon on the end. Let's see what it looks like when I forget it. I changed it, so it's going to rebuild. Alright, it says there were build errors. Boo. Would you like to continue and run from the last successful build? No, I do not want to do that. If I have build errors, I want to address them. Alright, and we can see down here build. 0 succeeded, 1 failed. Alright, there's this line here. What this line is telling me, this is directly output from the compiler, and it is telling me what's going wrong here. And you can see that it says, first off, it shows me the file that the error is in. I only have one file, so it's obviously this one. 9, it tells me the line that the error is on. It's on line 9. And then it tells me the name of the error. Error, syntax error, missing semicolon before close curly brace. And you can see that Visual Studio is also helping me out here. The same way that in Word, if you misspell a word, it'll underline it in red. The IDE will try to underline our errors in red. And you can see that it's showing me error expected a semicolon. All right, so it's showing me this. It's showing me this problem down here on this line, even though the problem is on the previous line. Okay, and this is a consequence of the fact that white space and new lines don't really matter in C++. Okay, I could put that semicolon anywhere before this little curly brace and it would work, but I'm not going to do that. I'm going to put it on this line where it belongs to make it easier to read. And so I put the semicolon back, and everything goes back to normal. The next one I'm going to show, it's not actually an error, but I'm going to show what happens when I don't have this end L. I was describing to you what happens, but I wanted you to be able to see it, so I rebuild. All right, here we go. And you can see what happens when I don't do a new line. So I have this hello world, but then immediately after it says press any key to continue. So that output that happened, that press any key to continue, it didn't get put onto a new line because I didn't put the end L. All right, so I'm going to put that back on there. And now it's working again. Alrighty, other common errors. Let's do this one. Let's take out the double quotes. Build it. No, I would not like to continue from the last successful one. Okay, when I took out those double quotes, I got a bunch of errors. This is an indication. This is something you're going to see commonly. This I count here. It looks like 5 errors from taking out the double quotes. The number of errors that you get when you compile is not an indication of how many problems you have. The compiler is trying to figure out what's wrong. It knows there's something wrong, but it's trying to help you understand what could be done to make it right. But it doesn't always do a very good job. And this is a case where it doesn't do a good job, okay? If you'll notice, look at all the things that it's trying to tell me. Hello, undeclared identifier. Syntax error, missing a semicolon before world. Okay, so it's trying to say it thinks there needs to be a semicolon, but it doesn't know what hello is. And it keeps on going. Syntax error, another missing semicolon, another syntax error. It just doesn't even know what to do with this now. Okay, so sometimes when you forget something and when you have a problem, the compiler just explodes on you. It's not a big deal. You just need to find out what the actual problem is. All right, and in this case, this is a really good example of one where the compiler did a very poor job in telling me what was going wrong. All right. All right, the next problem I'm going to do, this one's also a very common one. Instead of double quotes, I'm going to do single quotes around hello world. Now, one thing you'll notice is I'm not actually saving the file that I'm doing. Every time that you compile, Visual Studio will save all of your files for you. It is a nice feature. You can save if you want, but every time you build, it will save your code. And that is nice. Build errors. Here we go. Alright, it says on line 8, too many characters in constant. Alright, this deals with the fact that C++ single quotes are used to delineate single characters. I do not have a single character here. I have a bunch of characters. I have HELLO space WORLD exclamation mark. There's way too many characters for a single, so I need my double quotes to hold a string. Alright, put my double quotes in, and it's happy again. Other common errors you can have. Let's forget the parentheses and see what happens. Alright, error. Main looks like a function definition, but there is no parameter list, skipping a parent body. Alright, so you're going to learn what functions are later, and main is a function. It's a special function, but it's still just a function. And all functions need to have those parentheses. So if I forget those, that's what it's going to show me. Next common one. If I forget the void in front of main, Error, missing type specifier, int assumed. Note C++ does not support default int. Alright, once again, main is a function, it needs a return type. All of this will make sense later, but that is the error you will see if you forget this void. When you are defining main, you need all three parts. You need the void, space, main, open and close parenthesis. Alright, the next part, this using namespace standard, what happens if I remove that? Now you remember that I said that that line is difficult to describe what it does right now because you're just learning, but suffice it to say that I need that line in order to use the third-party code that's in IOStream. So if I forget it, I get these two errors. It says error cout, undeclared identifier, endl, undeclared identifier. Undeclared identifier just means that it doesn't know what that is. So you can see cout and endl are both included in this IOStream library. And because I don't have that line that lets me use that, it doesn't know what those are. Okay, it's included this, but I can't use it in this way. Alright? And this, you can kind of see that this is the effect, because if I forget the include statement as well, I get the exact same errors. Okay? So without that using namespace standard, it's as though I never included IOStream to begin with, and without including IOStream, I cannot use the code that allows me to print to the console. Alright? And so if I put those back, everything works again. Alright. I hope this made sense to you. I hope you were able to create the same code, get the same output in your version of Visual Studio. And in the next video, we're going to take a much deeper look at what goes into printing out to the console. We're just going to go into a bunch of the details involved in that and maybe just dive a tiny bit deeper into the syntax of cout. Until then.